Hi, this is Mr. Sloan. This is for environmental science. We're doing a little bit of fire. Talking about, we have all these fires going on in the West. May do this in a couple segments. So this is maybe just one segment. Anyway, what does it take to have a fire? It takes these three things. These are on your notes, by the way. These are fire notes. It's fuel, oxygen, and heat are the three things that it takes. Hence, that's why we see lots of fires in the summer. We end up having our heat, which kind of makes for dry fuels, because you do have to have fuels to be dry to burn, and hence that's why you have dry paper to start your campfires or whatever. And so that's kind of the basic thing. Well, for the most part, this is constant. The heat, that's every summer. And right now you're hearing lots of stuff about, well, this is global warming and get used to it. And that's not necessarily true. And I just want us to, I'm going to put a few things down just to kind of talk about that a little bit. But at fuel, the thing that we can do the most about with fires is the fuel. How do we manage the fuel? And that's a big part of environmental science. And you go to work for any agency that manages the Forest Service, the State Department of Natural Resources. It's all about the fuel. How do you manage the fuel? And also at your house. So, okay. All right. One of the most tragic things about fires, personal space fires, houses burn, subdivisions burn. So let's talk a little bit about that first. That doesn't really include forest, range, pastures, global warming, just a little bit here. Those are houses. Well, you live in a house, you live in a neighborhood like that. What's everyone do? You plant a bunch of trees so you don't have to see the neighbors. Over here, there's brush growing, there's trees. Oh, can you see that on the video?
Yeah.
Same thing over here. There's brush and trees, because isn't it pretty? Well, what happens after time is this becomes an indefensible space. So we will put defensible. A defensive space. So now we're not talking about big picture of fire. This is just a small picture. So it's really hard, you know, and maybe you've seen the news, maybe you haven't, but there are subdivisions in Oregon where they show, there's no houses left. I mean, house after house after house, because once it got going in there, there was just so much heat and so much fire and flame. It just basically goes from, you can't stop it unless you just have all the water in the world. And unfortunately, that's what happened. So these are not very defensible spaces. Now, an example of a defensible space, however, can you come over, does it go over to here?
I can.
A little bit, just because we're on the subject. Here's your house. Well, you don't have, you might have short grass that you keep mowed. You have short grass that you keep mowed. You have a tree way off in the backyard, like this. But basically, you're clear around your house. That's a defensible space. So here, you can defend it. Here, it's much easier to defend. And unfortunately, we don't think about this except right during fire season. Right now, these people are thinking, oh my gosh, I should have cut those trees down. I didn't cut them down. We shouldn't have planted these right here. The green belt, shoot, I saw a bunch of dead trees in the green belt. They were dead. I didn't say anything. Here, I'll put a couple dead trees in here. Because that's the other problem. Trees that are dead dying, I'm making them brown. I don't know if you can see that. Anyway, so you go, oh God, I wish I would have cut those dead trees out. And so And it's really hard to have, you defend your space because you got a bunch of neighbors. And if not everybody defends their space and houses are close together, it's really tough. And it's a tragic thing that happens. I kind of live in the country, so this is kind of what I have, this kind of situation here. However, I do have some trees close to, I mean, some of my trees are closer to my house, but I keep the pastures really mowed. There is clearing around the house, but we do have some trees that are close that if the fire was to come through my neighborhood, I would have myself to blame because I could take those trees down. They're mine, they're not my neighbors. And so that lets me think in this type of situation. And so the thing about a personal fire like this, you got to plan. I mean, you got to plan it. You got to think about it before the summer. You got to think about it every day, or not every day, but you have to think about it so you can plan it. So that's what that is. So there's that portion of fire. So you can stop, and then we'll go to the.
Yeah.
All right, we're on. So we talked a little bit a second ago about defensive space, and that's really, really tough. You got to try to keep dead stuff out of your yard, keep your yard mowed, and your neighbors all have to do the same thing. That really doesn't have a lot to do with worldwide fires or these huge fires we're seeing with thousands of acres. So let's just talk a little bit about the overall science or the climate science. Now, we have a book. We have the Miller Environmental Science book, and there's 2 or 3 chapters devoted to this, and we're going to be looking at those. But I just wanted to give you a quick heads up on this because in the news, they've been erroneous many times and very almost opinionated. So, a couple things here. I have a couple quick charts up here. This one is a global temperature chart. And I have the minus 1,000 year and 2020. So like 3,000 years. But really, I guess you know what I really should do? I should put this as a 10,000 years. Okay, so imagine this being 10,000 years, and also this one 10,000 years, because, you know, they love to tell us that global warming is showing up more every year, and we don't know that. We don't know that yet. We won't know that until your great grandchildren are 100. So, but we do know some things right now. So we're going to talk about what we do know. Anyway, here's the temperature, global temperature, and we see over time. You know, we've had ice ages, we've had hot spells, ice ages, hot spells. Here is the temperature of Earth. And it's, I mean, it's only, you know, it's a 5 or 6 degrees Celsius range, or whatever the range is. And you can look this up. I'm just saying that over time, we have these little batches and dishes, and then it gets hotter. And then it gets colder. But the whole time, there's little reflections back and forth that last 100 years or 50 years. And over time, we see this chart. And right now, we do see that in the last 100 years, we see that we are going up some. However, is it any different than the ups that we've already had? Not necessarily. You would have to look at those charts, and you can find many from NOAA and etc. Respected research scientists on the internet. Anyway, so we have that. This is, however, a carbon dioxide chart. And once again, this should also be 10,000 years. I kind of put minus 1,000 to 2020. Now, the carbon dioxide chart is a little different because the carbon dioxide chart shows the amount of CO2 in the atmosphere. CO2 is from volcanoes, burning fossil fuels, decomposing plant material, life on Earth, which is carbon-based as it decomposes, as you and I breathe, which doesn't have a whole lot to do with it. Lately, most of our carbon increase is due to burning, releasing in the atmosphere of either fuels or fuels such as hydrocarbons, gasoline, diesel, coal. So we see actually, and if this was a 100-year spike, we would see in the last 100 years, our carbon dioxide levels have gone much higher than anything we've ever seen historically. I mean, we see spikes, volcanoes, you know, hot spells where there's lots of fire on Earth. So we do see spikes throughout the recorded history of CO2. However, we have seen in the last 100 years that we started to rely on fossil fuels, and they're wonderful. I mean, we get to go places. Everybody wants to fly to Disneyland. No one wants to plow a field by hand. No one wants to take and grow fields of corn without a tractor. We use fossil fuels. Your food depends on fossil fuels. And you don't have to work so hard. You get to ride a bus to school or drive a car to school. You don't have to walk. Most of us could use a little more walking. But anyway, in the last 100 years, this is what's happened. So, when they say that this is climate change causing this, that's not necessarily true. What they can say is that, well, we do have huge spikes in our carbon dioxide, which seems to be maintaining. There seems to be a correlation between CO2 and temperature. Not that the Earth doesn't do this naturally. CO2 acts somewhat like a blanket. It wraps the Earth in insulation, temperatures increase, etc. So there tends to be a correlation there. What will happen in the end, we won't know. You and I won't live long enough to know. There is some truth that these fires that we've been having, because of the temperature, we may see more and more temperatures. That may be true. However, what really takes, as I showed you in the first segment, to make a fire is the fuel. So let's talk about fuel in a second, okay?